All right, so since we had the whole weekend, a little bit of review from Friday. Um, we created a new linked list. We created a new linked list. Um, and then we added Diana, Harry, Romeo, and Tom. We added 4 elements to that linked list. And then we're going to capture what our list looks like by using the first letter of each name. So right now our list is DHRT, so that we capture the order of our linked list. Other things from last week, linked list is a Java generic, so therefore it has the angle brackets in which we put the type of the element. We're dealing with strings right now. It could be any class. Since we specify the type here when we're declaring the variable, we don't need to specify the type here. It can be inferred, so that saves us a little bit of typing. And then we add Diana, Harry, Romeo, Tom. Remember this little E colon thing here is the IntelliSense annotation. Don't type the E in the colon. That's just to help us know the name of the parameter if we're trying to figure out how that method works. All right. Then we created our first list iterator. Okay, this was like the newest concept that we did last week. The idea that we're going to use a different class, a different object. Yeah. Oh my gosh, yes. That would be so much more helpful. Is that better? So the list iterator is a new object we're going to use whenever we do anything other than the most trivial operations on a linked list, like add last, remove first, stuff like that. And so we invoke the list iterator method on the linked list on staff, which is the variable that refers to the linked list object. It creates a new list iterator that iterates across elements of type string. And then I'm using that vertical pipe character by doing shift and the backslash, the key above the enter key, to type where the iterator is. Conceptually, we're modeling the iterator in this chapter as always between elements to make it easier for us to know the behavior when we say things like next and previous and add and stuff like that. Okay. So at the very end of class, we invoked the next method on our iterator that advances over the element here. So it's going to advance over Diana. So now the iterator is between Diana and Harry, and it returns a reference to the Diana, the value of that first node. We're ignoring it. We're not assigning it to anything because we don't care at this point, but it is returned. So we're going to do some more stuff with iterators now to get a sense of how all of this works. So let's actually use the return value. So we're going to say, again, shift asterisk enter, makes a nice little comment block in VS Code. And we'll say the next method also returns a reference to the element that the iterator is passing. So that would look like this. We could create a local variable called name of type string and say iterator.next. And then I'll capture that. That means we've iterated over Harry. So it's Diana, Harry, iterator, Romeo, Tom. And then let's print it. So again, I typed system and IntelliSense do you want system.out.println? I do, thank you. And then I can just type name here. And then I can do system again. And here I'm going to say expected Harry. So I've embedded a little simple test in here where when we run this, we can actually see if it works. So now that we're actually printing something to the terminal, I'm going to scroll back up here to the start of the main method and click on run. And it will pop open the terminal. It will run all the Java code. If you're curious, you can see it here actually changing the directory appropriately, compiling the Java stuff, running the Java thing, and you can see here where it prints Harry and then expected Harry. So that's a good sign. Our program's working as we would expect. Cool. All right, what are the other key methods of the iterator? We use the iterator when we need to add new elements to the linked list. So let's do that. I'll do another /star enter. And I'll say the add method inserts an element at the iterator position. And I don't think I shared this last week. This is an important thing. The iterator is then positioned after the element that was added. I think I left out that detail last week. That's a really important detail. And in my opinion, based on the reading that was assigned, I think the text is a bit confusing on this point. So that's why I'm emphasizing it today. Let's make this more concrete with an example. So we'll do iterator.add, and let's add Juliet. And let's update what that's going to look like. So we had Diana, Harry, the iterator. So we're still going to have Diana and Harry. At the location of the iterator is where Juliet will be inserted. The iterator is now positioned after the element that was added. So the iterator goes here. Romeo and Tom goes there. It is very rare that I'll criticize our textbook. I think Kai Horseman does a fantastic job explaining these concepts. I read many Java books before I chose this one for this class. And it's really the same book as we used in AP Computer Science. It's just like the rest of it. So, but there's a few parts which get a little confusing. All right, let's add one more thing. Let's add iterator. Let's add Nina. And so then we would have Diana, Harry, Juliet, Nina, iterator, Romeo, Tom. All right, so we've used the next method. We've used the add method. The other thing we do a lot with iterators would be the remove method. So let's write a comment block about that. /star enter. The remove method removes the element returned by the last call to next or previous. While this next thing is implied in what I just typed, it's really, really important. It's easy to forget. So just to emphasize it, the remove method can only be called once after calling next or previous. So we have to call next or previous before we call remove. And the element that's going to be removed is the one that was returned by calling next or previous. We can't call remove twice in a row. For now, that's going to seem kind of annoying. Next chapter, when we write our own linked list class from scratch, you'll go, oh, I see why there's this limitation. The authors of the Java Standard Library aren't just mean to us. There's a good reason why we can't call remove twice. But for now, we'll just accept the behavior and we'll better appreciate it later. Also, just to be clear, the remove method cannot be called after calling add. Okay? So we have to call next or previous. And again, these limitations will make more sense in the next chapter. All right, so we better call next. So iterator.next. And let's see what that does here. We're going to have Diana, Harry, Juliet, Nina. We will iterate over Romeo. So the iterator will be between Romeo and Tom. And then when we call iterator.remove, Romeo gets removed. and the iterator stays right where it is. If you don't follow these rules regarding the remove, you'll get an exception. And then you'll be like, oh, I must have broken one of the rules for remove, and you'll fix it and things will be fine. So let's print everything out because we've made some changes, and this way we can run it and make sure it looks. So I'm going to print. You'll notice I can just print staff, which is a variable that refers to the linked list. And much like the array list, it will print out a nicely formatted version of the linked list for me. So that's cool. And then I'm going to print the whole expected thing again. So I expect it to print Diana, Harry, Juliet, Nina, Tom. I know that's a lot of typing, but. So once you have this, run it and make sure that what's printed matches what we expect. I think the last method, second to last method on the iterator that we should highlight is the set method. So we focus on how we add new elements to the linked list. We focus on how we remove elements from a linked list. The set method changes the value of an existing element. So we already have an element there. We just want to change its value. It behaves somewhat similarly to remove, in that we need to call like next and previous. So the set method updates the element returned by the last call to next or previous. So very similar. So let's do we haven't done anything with previous yet. So let's do iterator dot previous. And let's capture what that's going to look like. So Diana, Harry, Juliet. The iterator was between Nina and Tom. So we said previous, so it's going to pass over Nina and be here. And then we have Nina, Tom. And then if we do iterator dot set and then do Albert, we're going to change Nina to Albert. And the iterator is going to stay in the same place. While there's certainly times when we're going to be using like next and remove and add and set kind of on their own, 80% of the time or more, we're going to be doing all of this stuff in the context of a loop. Okay. And so we traditionally use a while loop with our iterators whenever we want to iterate through the entire linked list, or at least up until some condition is met, and then we might stop. So this next code snippet, you're going to use over and over and over and over again. So let's capture that. The key method we use for this is the hasNext method. So the hasNext method is often used in the context of a while loop. And this might remind you of some of the stuff we did with scanner last year. And the way this looks is I'm going to create a new iterator because that's an easy way just to get back to the front of my linked list. I'm going to reuse the same variable, however. So I'm going to say staff.listIterator. So now the iterator is at the beginning of the list, and we still have Diana, Harry, Juliet, Albert, Tom. And then we write our while loop. We'll say while iterator dot has next. And then whatever condition we want, we put inside the body of our loop. So let's just say that we're searching for Juliet, and if we find Juliet, we're going to remove Juliet. So we can say something like string n equals iterator.next. So usually the while loop condition is almost always iterator.hasNext. The first line inside the while loop body is almost always iterator.next because we just determined it's safe to call next. So we call next, we get the value, and then we do something with it. In this case, we're going to check if n equals Juliet. And if it does, we'll call remove. Now what I want to capture here, I'm going to add another blank line and capture that we just called next. So I want to update our comment here to show that it's Diana, then Harry, Juliet, Albert. Oh no, just kidding. When this is true, it's going to look like this. So I can't like comment like, but this loop's going to run multiple times, right? Because the first time we call next, Diana's going to be returned. Diana does not equal Juliet. We're going to go back up here. Are there more elements? Yep. Get the next one. The next one is Harry. Does Harry equal Juliet? Nope. Loop around. Are there more elements? Yep. Get the next one. That's going to return Juliet, which equals Juliet. So when we are inside, when the condition of the if statement is true, and we're inside this block, this is what our linked list and iterator looks like. And then after we call remove, Juliet is gone. This will continue to run. We're still going to call has next and next. So when this loop ends, the iterator will be at the very end of the list because has next will then return false. And that's when our loop finishes. So you're going to write code like this little snippet a lot. Okay, this is like the most common way to iterate through a linked list when we need to make like changes to it. With array lists, we tended to write for loops because we knew how long they were, and it was very easy to get that. With linked lists, we tend to write while loops with the iterator instead, so a little bit different. One similarity, however, is with array lists, when we didn't need to modify the array list, we used an enhanced for loop. We can use enhanced for loops with linked lists as well. So let's add in an example of that. Enhanced for loops work with linked lists. Very exciting. All right. So in case the syntax is a little bit different, in case you don't remember, it's for, and then we declare a local variable, and the type has to be the type of the element. So I'm going to say string n, and then the colon and the variable that references the list. And when I read this in my head, I say for n in staff. I read it like as if it was Python, for those of you familiar with Python, which has a very intuitive syntax for stuff like this. And then let's just print stuff out. So we'll do system.out.println, or just print, because we'll put it all on one line. I'm going to print the name and then put a space after it. So I'm just formatting it slightly differently. And then outside of the for loop, I'll do system.out.println to get my new line. And then I'll do the expected thing again. So we expect at this point, Diana, Harry, Albert, Tom, all separated by spaces. So give that a run. So we can use enhanced for loops with linked lists, just like we used them with array lists. That's pretty convenient. However, when we need to modify the linked list, we should be using a while loop with the has, next, and next methods on the iterator, as opposed to a for loop like we did with array lists. So different approach there. All right. One thing I often like to do is to show you pitfalls that are really common to run into, so that when you do eventually run into them, you'll recognize them and you'll know how to solve them. Okay. So here's a very common pitfall. Let's copy and paste some code to save us a little bit of time. So I'm going to go up to where we made the iterator and we have the while iterator.hasNext. I'm going to copy this whole chunk and paste it down here. And then we're going to modify it some. Get rid of my comments. All right, so iterator, so we'll make a new iterator. I like that. While iterator.hasNext sounds great. String n equals iterator.next also sounds great. Let's say now we're searching for Harry. So if n equals Harry, previously we called iterator.remove, but there's also a remove method on the linked list object itself, just like there is on array lists. So we could say staff.remove, and let's say Harry and Diana don't get along. Okay, so we're going to say if Harry's in the list, we're going to kick Diana out, which seems really mean to Diana, but I don't know. So if we find Harry, we're going to remove Diana. So a slightly more complicated algorithm here, where we're searching for one element and then we're going to remove a different one, and we're going to use that remove method on the linked list. Go ahead and run this as well. Yeah. So let's scroll up. So this linked list here, you have to have the angle brackets and put string in that one. And then all those underlining things. Here, I'm going to show everybody that. Let me show you all a really good tip. This just came up, which is fantastic. So let's say I left out the type of my generic. See the little squiggly thing? It's like a Google Doc when you have something like misspelled or your grammar isn't correct. When you see stuff like that, that means something is most likely off. These are like warnings. And if you hover over them, it will actually tell you, if you scroll down, like what's going on. Linked list is a raw type. References to generic type linked list should be parameterized. Parameterized means adding in the angle bracket thing, right? And then you'll get all these other warnings. Type safety, okay? So this is all leftovers from before Java 5 that we're still dealing with, but we're going to put string here. And then all those warnings go away. You can also see all those warnings if you click over here on, if you have like your terminal and all your other stuff open, you can click on problems, and then you can see them all at once, which is pretty cool. My spelling is atrocious, so I also have an extension that helps me with spelling, and it doesn't like my abbreviations there. So anyway, good tips there. So we're going to put linked list here, and we're going to do string. Let me run this really quick, and we're going to pick this up tomorrow. You'll notice when, hopefully you saw the same thing that I got, we got an exception, and we got a concurrent modification exception, okay? So tomorrow we're going to dive into, I don't want to rush this because it's one of the key pitfalls we'll hit in this chapter. What is a concurrent modification exception, and how do we avoid getting it? Because we don't want those exceptions. So let's try to commit our stuff. And I know that this might be challenging for us. But again, if we go to source control here, we can type in a commit message. So we can say add notes on linked list iterator methods. And you should be able to just hit commit. and then sync. But I think a lot of you are getting errors on the sync due to something with like an upstream thing. So here's the workaround until I figure out what's going on with that. Go to terminal and say new terminal. And this is our terminal prompt. It should be your login name at the name of the computer you're at, and then the folder you're in. So I'm in the chapter 15 class notes folder. And if I do git push here, it will push everything to GitHub successfully. Okay, so I'm going to come around and just make sure we can all actually push our changes.